Testing, am I live? Testing, am I live? Yes, I am. Oh yeah, I need the chat overlay. Okay. It works. Oh no. We need this one. No, fuck. If I swap these, I can't get the donut. How did I do this? Oops. Filter. Okay, no. Oh fuck, do I need to code it again? How did I even do it? I mean, there has to be a better way, but I just don't know any other way. If x equals donut, then return price. And just copy this 4 times. Coast cat banana. Wow, that was fast. Guess some learning is happening. Took me almost 2 hours to get to this point. Now it was what, 10 minutes? Okay, this one I didn't even solve. Read the article. So only these move to the next iteration. Why would I need a shallow copy? Not sure why this is used. What? How can it be shallow if it isn't changing it? Yeah, I don't know. I don't know anything that's listed here. Yeah. Okay, do I even need to read it? I know how it works. True or false? What? This is true or false? Okay. Let us try. Okay, I feel like this is gonna be difficult. Maybe we should check if there's actually some materials for this. Is this the last week? Nothing on next week. Only the final assignment. I wonder who coded this page. This is a web dev course, after all. Okay, maybe they actually do teach them here. Yeah. Well, I never read these, so maybe that's why I'm struggling. What the fuck? Is this like supposed to be a good website? Okay, so I need to go down here. I seriously hate this kind of interactive websites. Let's check the PDF. Where is it? Okay, yeah, this makes more sense. Human potential unlimited. Is that some slogan of my school? Okay, the course is almost over and now I'm finding the materials. So I guess they do actually teach us something. What is this 4 hours?
To recap, first there was the Big Bang, then there was the dawn of man, and then there was JavaScript.
240p
I was
video.
the first person to recognize that JavaScript had good parts. That was the first important discovery of the 21st century. And when I announced my results, they were met with wild skepticism. No way, there could not possibly be any good parts in JavaScript. But it turns out that my results were validated, and in fact, JavaScript has some very good parts.
So this is the most important discovery of the 21st century, and you made this.
Yeah, I did that.
That's the job.
So, to give you some historical background, at the National Center for Supercomputing Applications at the University of Illinois, Urbana-Champaign, there are a bunch of kids who are developing a client program for the internet. At that time, there were a number of protocols that were being considered for the way that the internet was going to deliver information to people. There was WACE, Archie, Gopher, FTP, Finger, and a few others, and the World Wide Web. And these guys didn't know which of those was going to win, so they wrote a program that worked for all of them. And they called the program Mosaic. And because of the way that they implemented the viewer for the World Wide Web won. And the thing that they did was they came up with something called the image tag, which allowed the web to display images, which is something that the other formats couldn't easily do. And because the web could display images, it could look like what you wanted it to be, even if it wasn't what you wanted it to be, and that was sufficient. And that allowed the web to win, and everything took off from there. A bunch of the people from that project were lured to California, where they became part of a company called Netscape. Netscape made the first commercial web browser called Netscape Navigator, and it was a huge hit. It kind of disrupted everything. And they were then planning what to do for Navigator 2. And they added a bunch of new features, including support for electronic commerce. They also wanted to make it easy for end-user programming. They remembered something that had been on the Macintosh called HyperCard. HyperCard was a simple application creation program based on a simple metaphor of stacks of cards. And it was an event-driven script thing, and it was remarkably easy to use, and they wanted something like that in the web browser. So they gave that job to this guy. This is Brendan Eich, very smart guy. He'd been a kernel hacker at Silicon Graphics. His idea was he would write a scheme interpreter to do this. And he was told, no, don't do scheme. Do a language that people like. Make it look like Java or Visual Basic, something popular. This is for the kids. So he was given 10 days to create a prototype of this new interactive browser. And in those 10 days, he designed and implemented a new programming language, which is an amazing achievement. So from Java, he took syntax. In fact, most of the things that are wrong with JavaScript are things that were inherited from Java. There's a language called Scheme, which is a dialect of Lisp that was developed at MIT. And
interesting. Oh, there's even debugging information. Cool. Okay, this is what we need to check.
Did you know you can debug JavaScript in VS Code without having to install a separate extension? Well, let me show you how. What's up, everyone? My name is James Q. Quick, and I do weekly videos on web development related topics. And if you followed this channel at all, you know I've done a ton of videos on VS Code. It's my favorite text editor. I love the features. I love the customization. I love the extensions that come along with it. So you know how if you're setting up debugging for JavaScript in VS Code, wait, you actually do debugging more than just console log? Well, yeah, occasionally I do. But if you were to set that up previously, you would have to install a separate extension, the debugger for Chrome extension, so that you can do your debugging for your JavaScript applications inside of Chrome, or have it connect to your application running inside of Chrome, and then do the debugging right inside of VS Code. Anyways, you don't have to do that anymore, so let's take a quick walkthrough of how you would set that up. Now, before we do, I want to say that this video is sponsored by BenQ. They sent me a screen bar plus light, which hooks on top of your monitor, and I've got to use that for a few months now. Now, I have had some troubles with my eyes, of eye strain, just looking at monitors every day, and having that extra source of light in the right direction on the monitor has actually been really helpful. So I've got a couple of links below for you to check that out. If you're interested, you can find that and get one yourself. Now, let's dive into VS Code. All right, so I've got open a demo. So I've got a couple of links. Had some troubles with my eyes, of eye strain, just looking at monitors every day, and having that extra source of light in the right direction on the monitor has actually been really helpful. So I've got a couple of links below for you to check eyes of eye strain, just looking at
extra light
screen bar plus light, which on top of your monitor, and I've got to use that for a few months now. Now, I have had some troubles with my eyes of eye strain, just looking at monitors every day, and having that extra source of light in the right direction.
Seems like it's only gonna make it worse to see.
Direction on the monitor has actually been really helpful. So I've got a couple of links below for you to check that out. If you're interested, you can find that and get one yourself. Now, let's dive into VS Code. All right, so I've got open a demo for a video that's coming out actually right after this one. If it's published, after it's published, I'll put a card up here for you to check out. But that video is working with a form in vanilla HTML, CSS, and JavaScript, specifically working with a platform called Quiz Forms, which makes it really easy for you to handle form submissions on your sites. Anyway, what I want to do is just show you really quickly how I would go and debug this application. So previously, I would have to have installed the debugger for Chrome extension, which I actually still have installed here. But I want to get rid of that. So this is what I used to would have had to install. So I can go to settings and I can uninstall this completely and get rid of that. And then for people who this may be your first time doing actual debugging inside of VS Code, again, console log works most of the time, but if you head over to the little bug icon, the play button, that is your debug tab. Now, because this is built into VS Code, we can go right from here and do like a run and debug here. So the one thing we'll need to do is actually have our application running on some sort of local server. So we can use the live server extension. I've got a video about the live server extension if you need to know how to set it up. But once you have it set up, you can click go live. What that's going to do is start your application on port 5000. I've always said 5050. It's 5500, and then it'll have that as a live reloading server for you. So here's the demo. This will look a lot different by the time the video comes out. So with that in place, I can do a run and debug, and then it's going to ask me what kind of environment am I looking at. Well, I'm looking at Chrome. Let me know if you're using Edge, if you do, or what kind of browser you use when you do your web development. I use Chrome, so I'll choose Chrome here, and then it's going to basically give me this little configuration file, this JSON file that stays inside of my project. So if I look in my .vs Code folder, here's that launch.json file, which is now the debug configuration file for this application. And then all I want to do in here is say, hey, instead of looking at port 8080, I want you to look at port 5500. All right, so now I can save this, and then I can hit the little play button in the top left to go ahead and trigger the debugging instance. Now what this is going to do is not only set up debugging, it's also going to launch that. So this is going to launch the application or launch a page inside of Chrome at port 5500, and then it'll be connected to it via the debugger. All right, so we see that thing come up now. This thing, again, is connected to our VS Code instance. So what do we do? How do we actually debug? Well, the first thing we would do is create a breakpoint inside of VS Code to be able to do this debugging. And I actually just had a little bit of issue adding breakpoints a second ago. So what I did was restart VS Code. I quit it and opened it back up, and now my breakpoints are here because they kind of disappeared, which is a little odd. I'm assuming this will be a bug that will get figured out over the next, usually they're really good in the next couple of weeks, I would imagine. So hopefully you don't see this. But if you do, give it a restart, especially after you uninstall the debugger for Chrome extension. But now that I have my breakpoints available to me, I can set a breakpoint right at the start here, the first couple lines, so that when the JavaScript loads, it should hit this breakpoint. So let's go over to our debug button again. Let's run this. I killed the debug setup with the square here, and then just restarted with that play button. So this actually opened while I was talking. This opened the application in the browser, and then it also then hit this breakpoint. And so the beauty of this, beyond just console log, is you can go in and you can look at your variables. So you can look at, there's a ton of stuff inside of global. Here's a couple of our variables. So our meme input and then our preview image. Fast forward to the video coming out a couple days, we'll show you how to create memes to make fun of me, which will be fun. So you can inspect your variables here, especially as they change. And you can also go like line by line inside of your code. So if I look over the hover options in the debug options, I can step over, which will basically take me to the next line. And now if you look at preview image over here, now you see this actually is representing a DOM element. Whereas before it hadn't ran that line of code yet, or it hadn't ran this part of the code. So it didn't actually have a value. All right, so that's really cool. And then what we can also do is maybe go ahead and play this. So if we go ahead and hit play, this will continue in the application. And then what it's looking for, or what the callback function that I just set the breakpoint in, is if this input changes. So if I go to me and I upload an image of a me, for example, this should now hit that breakpoint. It will take me from Chrome back to VS Code, and I can go and inspect this again. Now I can look to see if I had some sort of logic to say, I want to know, is that file actually being picked up the way I'm trying to get it here? Well, I can actually go and see, hey, this thing actually is a file. Then I can go step by step again to do the rest of my debugging. This is a huge advantage, although it is slightly, it's not even tricky. It just takes a minimal amount of time to set up. There's a huge advantage of using true debugging in VS Code over just console log in your browser. Now that's not to say that I don't use console log most of the time myself, but this can be really, really handy if you're getting into a trickier situation with debugging inside of VS Code. So now this is as easy as it could get. You don't have to install a separate extension, and then you can create your configuration right inside of VS Code. They guide you through it. You can update that launch.json to match the port that your application is on, and then you'll be good to go. So I'm curious, how much time do you spend actually debugging versus console log? What does debugging mean for you? Does it mean a true debugging experience with breakpoints, or does it mean console log? Let me know that in the comments below. Thanks as always for checking out the video, and I will catch you next time.
Okay. I actually already have that installed, I just never used it. Good to know. Debugging is great. What are these? What? 150 submissions. What is this even? What points are these? Confusing. Do I need to pass those? No, it's just gonna limit my grade. So I suppose it's this final assignment. D3 chart. Wonder what that is. Okay. So much work to do. But most of it I don't need to do to pass the course. feel like I've skipped most of the course by now. Okay, they're actually teaching us something here. Yeah, I kind of skipped this part. Yeah, no wonder it was a bit difficult to do this. Am I gonna be able to pass this? I mean, I could try. But I still don't know how I'm supposed to do this. Other than with if statements. First is fries, then umbrella, ghost donut, fries cat, the banana melon. So I need to keep these ones. What's this filter? Yeah. So I need to, keep these ones and these ones. I mean, that sounds kind of easy if I just do it like that. Like these are arrays, this is a string. And let's see if we now I'm making the map function. The filter works different. Does this mean it's not in there? -1. Okay, -1 if not found. I don't really like this. It feels so dumb. Feels so dumb. Should I do something else? Maybe something from the previous week. Which day is it? Is it Tuesday now? Yeah. I don't know. What should I do? This would be actual coding. Let me try making this one. Let's read. My favorite. Yes. Oh, Haskell. Yeah, I bet they use neural networks now if this is from 2015. What is FXL? It's a language. In-house FXL language. Elm. No runtime errors in practice. Why is that? Probably because it doesn't work. Unless you, I mean, okay, I need to go get some water. Years ago. How is this any good? Oh my god. Okay, this answer makes sense. What? What code doesn't? Oh, I see. Global variables. My friend. What? Oh. This feels so complicated. So if we have hi, then say hi, or if we have something else, say hello. Yeah, starting to like C even more now. Much simpler. Great. What the heck? This was spread. How is this any good? Yep, I think I'm not even gonna try to understand it more. Oof, starting to hate JavaScript. Oof. Take me back to C. Does console log have side effects? I don't think so. I don't know. Let's guess. I think it's pure. Oh my god. Okay, guess we can just guess that this is correct, as these are the same. And here we have a HTTP request, I think. Spread the numbers and 5. This seems pure. We are manipulating the document here. Here we can't know what the date is now. $24 points. Oh, it also has this one, maybe that's why. Were others correct? So Am I mutating the data? Let's guess. Whoa. Cool. Okay, I got it done. Yay. Some progress. Is this gonna be long? 15 questions. Oh, this seems cool. Multiple choices are always nice. This seems correct. Yeah, not correct. Oh, or 5. Okay, there's and. So this is correct, right? What does reduce even do? This kind of looks like it's doing some yeah, I'm gonna have to read up on the reduce. Oh, yeah, also I'm gonna have to go pee. Toilet break. No comments on during this stream. Time for some nicotine. Passing in the return value from the calculation on the preceding element. I don't even get it. What? Over. Is this like a new line? Dude. Fuck. Is this the first value? Is this summing it up? And adding 10. Uh, 41 plus 60 is 101 minus 3, 2, 1, 295. Okay, here we actually have the solution for the question. So it's this one. Cool. Please don't ask me to code that. Multiple choices are really good. For learning. Oh, I'm getting tired. How many questions? Oh my god. Oh, can I actually submit my unfinished? Yeah, I can. Let's get some points. Cool. Then I can try to finish it later. Yeah, that was cool. Ooh. This seems correct. Here we have full name. It's not the same. What's the difference here? the name is. I'm tempted to answer this one. Cool, it was correct. I don't know. Chat, please help me. Anyone know which one this is? Think this one maybe. No. Can I redo it? Oh. I can just wait. So I can just guess. seems like the previous one. This seems correct. Or yeah, I need the length here. So it seems more correct. This is in the wrong order. No length here, so this one. Cool. Oh my god. I'm getting too tired. Gotta try to finish this one and then I'll be done for today. Split. I don't know what this does. Can we copy this? Let's ask AI. So split the words and get the length. Ah, okay. Okay. What? I still don't get it. So we get an array of the words, and then we get the length of the array, meaning the number of words. Okay. Whew. Eight, halfway there. Oh my god. And it's getting more difficult. I think I'm gonna stop here for now. I can do it later. Yay, we got more points. How many points do we have? Yeah, still getting that grade 2 for the course. I would need to make, well, I would have to get 250 from exam, so 329 points to get the 2. Is there more? So I need almost 600 points to get the grade 3. Yeah, maybe if I do this, it's possible. Oh my god, I kind of want to watch this though.
Scheme has lambdas. That's what Scheme calls its functions. And he took Scheme functions and he put them into his language. And there's a dialect of Smalltalk called Self that was developed first at Xerox PARC and then later at Sun Labs. Self took Smalltalk, which was the first modern classical language, object-oriented language, and made it better, both better performance and more expressive, easier to use, by removing one feature from Smalltalk. It's uncommon where someone makes a new language by removing things from another language. Usually it's adding more stuff. The thing they removed from Smalltalk was classes. By removing classes, they could make it faster and they could make it much better to program. And so he took that idea and put it into his language, and Netscape called it LiveScript. Now, while that was going on, there was another language that was being developed by a guy at Sun named Jim Gosling. He started with something called GreenTalk. He was then moved into a new company that was developing set-top box applications. There, his language became called Oak. That company failed, so he was brought back into Sun, and they tried to figure out what do we do with this language now. The internet was becoming popular, the web had become popular. They wrote a web browser in this language. That browser called Hot Java was wildly successful, at least for a short time. And the language that they wrote it in had its name changed to Java, and it became wildly successful. So much so that Sun was making noise that the Java language was going to be the future of software, that if you design all of your programs to target the Java virtual machine instead of the operating system, we can be liberated from Microsoft. And that was a wildly successful message. And Java shoots up like that. It is the most successful launch of a new programming language in history. It's amazing. At Netscape, they're making similar claims. They're saying if you design your applications to target the web browser, it doesn't matter what operating system we're on, and again, we can be liberated from Microsoft. Now, these two companies realized if we're both going after Microsoft, we'd probably better work together, because if we don't, Microsoft will play us off against each other and we'll both lose. So they form an alliance. And the first thing they agree on is that Netscape adds Java to the web browser. And in exchange for that, Sun will drop their Hot Java browser, which wasn't very complete anyway. So check, that's easy to agree to. Step number 2, Sun says you have to kill LiveScript, because that's an embarrassment. We're saying that Java is the last programming language you'll ever need. You can't then also be introducing another new language. You're just making us look bad. So kill it. Netscape refused to kill it for 2 reasons. One is they wanted a language for beginners, and Java ain't that language. You need a lot of specific knowledge about Java just to write Hello World. They wanted something with a much lower barrier to entry. But there's also a practical problem. They wanted to launch the new browser right away. And so the way they put Java in was they had Java talk to LiveScript through an interface called LiveConnect. So LiveScript could talk to the browser, Java could talk to LiveScript through LiveConnect. And if they took LiveScript out, Java wouldn't work. And so in order to get Java in there, they'd have to delay the launching of the new browser, and they didn't want to do that because they were on internet time, and they couldn't afford to wait that long. So their alliance was at an impasse and almost failed when one of the founders of Netscape, maybe as a joke, suggested that they change the name of LiveScript to JavaScript, and that they position it not as a new language, but as a subset of Java, interpreted Java, which was silly because Java was interpreted Java. It was Java's stupid little brother. So they went out and held a press conference in which they lied about the relationship of these two languages. And echoes of that lie still reverberate pretty loudly through the internet. Meanwhile, Microsoft has noticed that there are these two companies in California that are getting ready to destroy Microsoft, and they weren't ready for that yet. So Microsoft had completely missed the web and the internet. They thought the future of telecommunications was going to be fax and cable TV. So they went out, they bought a browser company. It was another spinoff out of Illinois called Spyglass, took their thing, relabeled it as Internet Explorer, and decided we need to get one of these JavaScript things too. So they put a team on reverse engineering the first JavaScript engine. Now it turns out 10 days is way too short a time to design and implement a programming language. And there are lots of errors, lots of bugs, lots of design defects, lots of blunders. The Microsoft team discovers and carefully documents all of them and replicates them. Now usually when Microsoft goes to knock something off, they can't help doing their own thing to it. For example, when Bill Gates told them, I want a Macintosh, they built Windows. Okay? He didn't ask for Windows, he asked for Macintosh. That's how it goes there. But on this case, they got it exactly right. And in fact, they were able to keep the once run everywhere promise that Java was failing to keep. In fact, having not done that, we wouldn't be talking about this language today, but we'll get to that later. But they couldn't call it JavaScript because Sun had claimed ownership of the JavaScript trademark, even though they had nothing to do with the development of the language, because they claimed to own the word Java. In fact, they were shaking down coffee companies for daring to have the word Java in their URLs. This is true. So they called it JScript, just as they called their implementation of Java J++, because they couldn't get a license to use the trademark. So now Netscape is alarmed that Microsoft is going to embrace extend us. We're going to lose control of JavaScript. What are we going to do? We need to make a standard. So they went to W3C and said, W3C, we have developed a programming language for the web. We'd like you to help us make it a standard. Now it turns out W3C had been waiting for a chance to tell Netscape to go to hell. So they told Netscape to go to hell. So Netscape then went to ISO. Eventually they end up at the European Computer Manufacturers Association, which is a long way to go for a California software company. But ECMA agrees, yes, we'll help you make a standard. So they convene a committee. Microsoft joins the committee. Microsoft dominates the committee. Basically, the standard is based on Microsoft's notes that they made in reverse engineering the original JavaScript interpreter. And they insist that all of those bugs, all those blunders, all those defects remain in the standard, where they still exist today. So there's a lot that's intentionally wrong, which will never be repaired. Now, when they went to publish, it was what we call the standard. They can't call it JavaScript because that's a Sun trademark. So they kick around other titles, WebScript, NetScript. They can't agree, so it's published with a working title, ECMAScript, which is maybe the worst name ever put on a programming language. And confusion still exists today. What's the difference between JavaScript, JScript, and ECMAScript? There are people out there who think that they are three remarkably similar, but different. No, they're three silly names for one silly language. So JavaScript is a standardized language.
Interesting.
The edition that is in most versions of IE is the 3rd edition, which was published in December of 1999. Before that one was finished, work began on a 4th edition, which went on for 10 years and was abandoned. In 2009, a 5th edition was published, which defines two languages, a strict and default. We'll talk more about that dialect this afternoon. And then recently, the 6th edition was published, and which will eventually find its way into browsers. We'll talk more about that on the 3rd day. So where do bad parts come from? I think there are 3 sources. One is legacy. A lot of what happens in any language is repeating mistakes that happened in previous languages. And most of what is wrong in JavaScript is not unique to JavaScript. It's wrong in lots of other languages too. For some reason, it just looks stupider in JavaScript. I don't know why that is the case, but it is clearly the case. Another is good intentions. There were a number of features that were added to the language to make it easier, which failed to make it easier. Things like with, semicolon insertion, type coercion, implied global variables were all intended to make the language easier for people, but they actually make it much harder, at least for professional programmers. And then haste. 10 days is just way too short a time to design and implement a programming language. Brendan did not intend for his proof of concept to be shipped as a product, but Netscape did that. I think that was inexcusable. And he suffered for that. It was an unfortunate thing. So for the most part, to give you a comparison, maybe the best designed programming language in history was Smalltalk 80. Xerox PARC spent a decade designing, refining, testing, improving that language. They spent almost as many years as Netscape spent days in designing the language. And I think Xerox got it right, even though the community did not agree. So for the most part, the bad parts can be avoided, which is great. The problem with the bad parts isn't that they're useless, it's that they're dangerous. JavaScript is an object-oriented programming language, but what it thinks an object is different than most other object-oriented languages. In JavaScript, an object is simply a dynamic collection of properties. Every property has a key string that is unique within that object, and that key string will be associated with any value. You can get a property from an object by using the dot notation or the bracket notation. They can be used in some cases interchangeably. If the bracket contains an expression which is a string which is the same as a name, then you'll get the same property. That makes it possible to dynamically get at things without use of a reflection API. You can set properties of an object simply by assigning to those properties. You can add new properties or modify old properties simply by assignment. And you can also delete properties from an object using a delete operator, although I very rarely see this used. Generally, once an object is made, it keeps its stuff. One design mistake in JavaScript is that the keys must be values, or must be strings. It would have been better if they could have been any value, but they're not. So you can pass any type into the brackets. JavaScript will turn that into a string. So that means effectively the values have to be strings. We have a very nice object literal notation. JavaScript's object literal notation was the inspiration for the JSON data interchange format, the world's most loved data interchange format. And you've got curly braces that identify the object, and then you've got named fields or properties within the object. If you don't have to put quotes around the names if the names are valid identifiers. If they're not identifiers, then you need to put the quotes around them. So most object-oriented programming languages are classical. They're all about making classes where objects are instances of classes and classes inherit from other classes. JavaScript has a much simpler, much more highly evolved design, which is based on prototypes, where objects inherit from objects, and that's it. There are no classes. This was the idea that we got from Self, which was an improvement over Smalltalk. But it's a really controversial idea, and most people who are writing this language do not understand how this really works, but we're going to talk about it. So working with prototypes is actually very easy. You make an object that you like using any of the techniques available for making an object. You can create new instances that inherit from the object, and then you can customize the new instances by assigning new properties or replacing properties. The classification and taxonomy operations that you have to do in an object system, in a classical system, aren't necessary, which turns out to be a huge win. So if you're working in a classical system, when you start off, you have to classify all the objects. You have to figure out what are all the objects, what are they composed of, how are they related. Then you make a taxonomy in which you figure out what's going to inherit from what's going to implement what. And it's a really complicated hierarchy. And usually you're doing that work at the point of the project, usually the beginning, where you have the least understanding of how the object system is actually going to work, which means it's almost certain that you're going to get it wrong. And you see that in that things don't compose properly. You just can't, they don't work. You find yourself wishing you had multiple inheritance because there's no way to get from here to there. And as you layer in more and more classes on top, you find that brokenness starts to seep up into all the higher layers, and eventually reach the point where it's so broken that you have to refactor, which means you have to tear it all apart and put it back together again, which is really dangerous because there's a chance it might not ever go back together again. And all of that is due to the coupling of classes. And if you get rid of classes, you don't have to do any of that, which is really quite remarkable. So the model that JavaScript provides is sometimes called delegation, where an object can only do what it can do, and if it's asked to do something that it can't do, it will designate another object to do that work on its behalf. This is also called differential inheritance, where each object will only contain the material which distinguishes it from the object that it inherits from. The primitive in JavaScript for making a new object is object.create, where we pass it an object, which unfortunately is called a prototype, and we make a new object that inherits from the old one. The word prototype here is problematic because it's so overloaded. All it means is this is the object that we want to inherit from. So let's diagram this. I'm going to make an object called mother, which will have two properties, A and B, whose values will be 1 and 2. And this is the data structure that is created. So we've got our key value pairs, and we also have an invisible pointer to object.prototype. So whenever you make an object literal, it will ultimately inherit from object.prototype. Then if I make a daughter object, I'll use object.create mother, so I now have a daughter. So I've got an empty daughter object, which inherits from mother. So if I say daughter.b plus 2, originally there's no value here, so we get the inherited value of b, then we add 2 to it and store it in the daughter. So storing operations will always go into the topmost object, but reading operations can go all the way down the prototype chain. And we can have these chains go as long as you want. Generally, chains in this language tend to be very shallow. We don't get the deep hierarchies that you tend to see in classical languages, but if you want to go deep, you can. Then we can add material to the daughter object, which has no relation to the mother object, so we can add more stuff. So generally the way we'll use this is the mother object will be where we put the methods, and then the instances will inherit those methods. Okay? There's also a form object.create null, which will make an object that inherits nothing. So you get an object that does not inherit from object.prototype. This is handy if you want to make something which is just a container of stuff, and you don't want to be confused by stuff that you might inherit from object.prototype. So that this will act much more like a hash table. Everything in JavaScript is an object. So numbers, boolean strings, arrays, dates, regular expressions, and functions, they are all objects. So let's look at numbers. Numbers are objects. It's a much simpler number system than you have in Java, in that we don't have ints and integers. We don't have either of those, we just have numbers. We make numbers with number literals. All of these number literals refer to the same object. There's only one number type in JavaScript, which is actually a very good thing. And there are no integer types, which is something that it's actually a good thing too. But the problem is that the one number type we have is the wrong one. It's based on 64-bit binary floating point from the IEEE 754 standard, which is strangely called double in Java and other languages. Anybody care to know why it's called double? Why they picked such a silly name? It's something that comes from Fortran. Fortran had integer and real, and later they added double precision, which was 2 reals put together in order to give you more precision. And C took Fortran's double precision and shortened it to double, and everyone else has been using double ever since then. So we don't have ints, and I'm glad we don't have ints because I hate ints. ints have some really strange properties. For example, we can have two ints which are both greater than 0. We can add them together, and we can get results that are smaller than the original numbers, which is insane and inexcusable. And how can you have any confidence in the correctness and the perfection of your system if it's built on a number type?
I don't get it. Why would this be?
Which can do such insanely ridiculous things. So JavaScript does not have this defect in it, which I think is brilliant. So one problem with computer arithmetic in general is that the associative law will not hold. And that's because computer numbers are necessarily finite and real numbers aren't. So in many cases, we're only dealing with approximations. And when the values are approximate, then associativity doesn't hold. Now, if you're just confined to the integer space, JavaScript integers go up to around 9 quadrillion, which is pretty big. And 9 quadrillion is bigger than the national debt. So that's big, right? That's big. So as long as your integers are smaller than 9 quadrillion, they work out exactly. When the integers get above 9 quadrillion, they don't do the crazy wraparound thing that ints do. They just get fuzzy. So if I take a number above 9 quadrillion and add 1 to it, it's like I added 0 to it, which is not good, but it's much less bad than what ints do. And because computer arithmetic can be approximate, then there are identities that we're used to thinking about which don't hold. So you need to be aware of that and cautious. So the most reported bug for JavaScript is that 0.1 plus 0.2 is not equal to 0.3. And that's because we're trying to represent decimal fractions in binary floating point. And binary floating point cannot accurately represent most of the decimal fractions. It can only approximate them. But it approximates them with infinite repeating bit patterns. But we're not allowed to have infinitely long numbers, and so they truncate, and so they're going to be, every number is going to be slightly wrong, which is only a problem if you're living on a planet that uses a decimal system. But on such a planet, you're counting people's money using this. When you're adding people's money, they have a reasonable expectation you're going to get the right sum, and we're not guaranteed to get the right sum with binary floating point, which is a huge problem. Numbers are objects, and so numbers have methods. You don't have to box them in order to get object behavior. Every number is already an object. Every number inherits from number.prototype. So if we wanted to add new methods to numbers, we can do that by adding them to number.prototype. This is not something that applications should ever do, but it is a useful thing for libraries to do. In fact, this is how we evolve the language. So we can add new methods to new versions of the standard, and libraries can backfill old browsers and old implementations with the new stuff, as long as the new methods can be implemented in JavaScript. Numbers are first-class objects, which means that a number can be stored in a variable, can be passed as a parameter, it can be returned from a function, and it can be stored in an object. And because numbers are themselves objects, they can have methods. JavaScript has made the same mistake that Java made in having a separate math object, or math container, for keeping the higher elementary functions. This was done in Java, anticipating that in the future there might be very low memory configurations, and they'd want to be able to remove the math functions. But that didn't happen because Moore's law kept cranking on memory capacity, so that turned out not to have been a good strategy. But it wouldn't have worked anyway, because you'd be throwing away essential things like floor. There's no good way to get the integer part of a number if you get rid of the floor function, so it couldn't have worked. There are also some constants stored in the math object as well. So one of the things that we get from the IEEE format is something called nan, which stands for not a number. It's the result. It couldn't have worked. There are also some constants stored in the math object as well. So one of the things that we get from the IEEE format is something called nan, which stands for not a number. It's the result of confusing or erroneous operations. For example, if you try to divide 0 by 0, the result is nan. Nan is toxic, which means that any arithmetic operation with nan as an input will have nan as an output. And despite the fact that nan stands for not a number, it is a number. If you ask JavaScript what is the type of nan, it says number, and it's right. The thing I hate about nan is that nan is not equal to anything, including nan. So nan equal nan is false, which bugs the hell out of me. And even worse than that is that nan not equal nan is true, which I hate even more. So if you want to find out if something is nan, there is a global isNan function. And you can pass nan to it, and it will return true, which is good. Unfortunately, isNan also does type coercion. So if you pass it a string like hello world, it'll try to convert the string into a number. The number that hello world turns into is nan. So hello world is nan, which is not true. So ever since Fortran, we've been writing statements that look like this. X equals x plus 1, which is mathematical nonsense. So Algol got this right. Algol came up with an assignment operator, so this didn't look so ridiculous. And BCPL did the same thing as Algol, which got it right. Unfortunately, Thompson liked this better, and so we reverted back to it, and we have not evolved away from this since. So we're stuck with this. And it looks crazy, right? Because it looks like an equation, but there's no value of x, which equals x plus 1, right? So it's, except it turns out, if you're using binary floating point, there's a value called infinity. And if you add 1 to infinity, you get infinity. So this actually is an equation. There's a value of x for which this is true. And not just that, there's another value called number.maxValue, which is 1 followed by 308 digits. It's a really big number. And if you add 1 to the biggest number that JavaScript knows, you would think that would be infinity, but it isn't. It'll be max value. So it holds. In fact, that is true for every number above 9 quadrillion. So there's a lot of values for which this holds. But not nan. Even though nan plus 1 is nan, nan is not equal to nan. So I hate that, and nan is, I hate that even more. So booleans. There are exactly 2 booleans in this language, and they're true and false. So hooray, we got that right. We have strings. Does anybody know why they're called strings? Anyone?
The chains of characters.
It turns out nobody knows. The first place I've been able to find in the literature that refers to a specific data type, which is a sequence of characters, is the Outlaw 60 report. But there's nothing in that report which explains why they chose the word string. I mean, the first time you encountered it, you must have thought, well, this is strange because it doesn't look like a piece of string in any way. So how'd that happen? I asked John McCarthy, who was on that committee, he was the inventor of Lisp, why did he call it strings? And he said, well, Klein was doing this stuff with strings of symbols. So, but that didn't really answer the question, because at the time of the Outlaw 60 report, they would talk about strings. A block was a string of statements. So when did it become specifically a string of characters? And he was really annoyed that I was asking the question he didn't know the answer to. So that was the end of that conversation. And then he died, and he was the last survivor of the Lisp committee, so we'll never know, or the Outlaw committee. So anyway, we got him. We call them strings. And I think we call them strings because there may have been some CPU architecture which linked characters together to make string sequences of characters. And I think that because what's the operation we do on strings? It's concatenate. But concatenate means to form links. It's an operation in chain making. So you would think if it's strings, it should be tie, or maybe slice, or wine, or something that strings do. So we've got some mixed metaphors going on. And so I'm still searching the literature, trying to find out where strings came from, but I haven't found it yet. So anyway, we got them. We got strings. A string is a sequence of 0 or more 16-bit Unicode characters. It's characters in the sense of UCS2, not UTF-16, because there's no awareness of circuit pairs. At the time that JavaScript and Java were designed, Unicode was going to be a 16-bit character set. It later grew to a 21-bit character set, and JavaScript is not aware of that. There's no separate character type. Characters are represented as strings of the length of 1. Strings are immutable, which is good. Once you make a string, it cannot be changed. It's fixed for all time. You can make new strings by concatenating together bits of old strings, but you cannot change a string once it's made. Similar strings are equal, which is great. Java got that wrong. JavaScript got that right. Hooray for JavaScript. String literals can use single quotes or double quotes with a statement. Both work exactly the same way. No magic quotes or quasi quotes or anything like that. But there's no reason to have two ways to make strings, but we do. So given that, I recommend use double quote for external strings that make sense outside of the program, like URLs and templates and notes to the user, that kind of stuff, and use single quotes for internal strings, like the names of properties and character constants and stuff like that. There's nothing that enforces that, but I think it's a good convention. We can convert a number to a string by using its toString method. I prefer instead to use the global string function, which does the same thing, and will also work better on things that do not have toString methods. We can convert a string into a number by using the global number function, or by using the plus prefix operator, which I prefer. We also have a parse int function that I don't like. Parse int is something that was borrowed from Java. It will convert a value into a number, but it stops parsing at the first non-digit character. And it won't tell you where it stopped or why it stopped or what was left over. And you usually want to know that, because that can be important, but it doesn't give you any clue. There was a big design error in that if the string you were parsing starts with a 0, it assumes that you meant that to be parsed as base 8 octal. And so if you're parsing something like a date or a time, which might have an 08 or an 09, that will be parsed as a 0, because it sees the 0 goes into base 8, it sees 8, says you are not an octal digit, so I stop here, and you get the 0. Yeah, so because of that, I recommend you always include the radix argument, which says base 10, we're on planet Earth, damn it, you get base 10, 0 to 9. Strings have a length property, which tells you how many 16-bit characters are in the string. Surrogate pairs will be counted as 2 characters in that count. Strings are objects, and so they contain a big mess of methods. I'll let you look them up offline, but there are a lot of them. Many of them are actually very useful. Every string inherits from string.prototype, mess of methods. I'll let you look them up offline, but there are a lot of them. Many of them are actually very useful. Every string inherits from string.prototype. So if we wanted to add new strings to new methods to strings, this is the place where we can do that. Again, this is not something applications can do, but this is how we've been growing the language. Array is one of the fundamental data structures. It's a contiguous series of span of memory divided into equal-sized slots where each slot is indexed by a number. Very fast, very efficient. JavaScript doesn't have anything like that. Instead, what JavaScript does is, well, the first version of JavaScript forgot to put arrays in, and people figured out that, well, we can just use an object, right? We can use the bracket notation, we can pass numbers, the numbers get turned into strings, and it all kind of works like an array, sort of, and that's still what we do. So there is now an array data type. It inherits from object, and the indices are converted into strings and used to retrieve and store values. The good news is that is extremely efficient for sparse arrays. Unfortunately, we don't do sparse array stuff. We're almost exclusively doing dense array stuff, and it's very inefficient for that. One other advantage it provides is that there's no need to provide a length or a type when creating an array. You can just say empty angle brackets, that's a new array, and then you can add as much stuff as you want to it. You don't have to worry about out-of-bounds errors because it's not really an array, it's a hash table. So every value is in bounds. Arrays, unlike objects, have a special length property. And that property is always 1 larger than the highest integer subscript, which is not necessarily the same as the number of elements in the array. So we can make an array with an object literal or with an array literal using the bracket notation. We can have multiple expressions in there separated by commas. Each of those will provide a value to an element. We can append to an array by assigning to its current length, which is really weird looking, but it works. So in this case, my list.length is 3, so we'll assign to it, and the length will now be turned into 3 plus 1, 4. Arrays come with a more interesting set of methods than objects have. Objects have very little useful stuff coming from object.prototype. This stuff is all stored in array.prototype, much more useful set.
Okay, I think I'm gonna have to go sleep. Oh, I'm gonna end the stream here. See ya tomorrow, I suppose, if I'm not going to Labor Day parties, which I don't think I will. Good night.